Hi, I'm Christian Carpio from the Husky Robotics team at the University of Washington. We're a student-run organization and in our third year. Since previous years, we've grown from 8 members to 75 members, and we're still expanding. The next few minutes, I'm going to talk about what we plan to do for the University Rover Challenge. As outlined by the rover requirements, our rover design is intended to be used on the Martian surface. Since our focus is on surface operation, as opposed to interplanetary communication, our chassis design differs from standard NASA rovers. We are using a tank-based, track-driven design which grants us greater traction and maneuverability. The track design also allows us to mount our motors farther from the surface, minimizing the risk of motor injury. As for the suspension system, we are implementing an easily adjustable pneumatic system for smooth operation over varied surfaces. For the equipment servicing, we are putting much time and effort into developing an arm capable of enough dexterity to interact with equipment. This year, our arm and hand have 3 degrees of freedom each, affording us our desired limb movement. Our wrist contains 3 high-torque 180-degree rotation servos, allowing a wide variety of angles to be reached. The wrist assembly is mounted onto another inline servo, giving us the ability to rotate knobs. Finally, a worm drive is being used to actuate the hand's grippers for significant grip strength. The goal this year is to exceed the requirements defined by the URC. For soil extraction, we are implementing a linear actuator-mounted auger drill. Our previous arm design didn't have the required downward force to properly drill into the topsoil. By mounting our drill on a linear actuator, we hope to achieve better results. For sample testing, we are focusing on soil pH. We are creating a testing apparatus containing 6 single-use capsules capable of measuring soil pH and preventing possible cross-contamination. The electronics on board our rover will be more robust than previous years. We have chosen to double our operating voltage from 12 volts to 24 volts in an effort to reduce the current. We will also be using a secondary battery source dedicated to supplying more sensitive electronics. Since many of our electrical systems have different operating voltages, we're using top-of-the-line DC-DC converters to accommodate them. The final and most important step will be integrating the mechanical and electrical systems together. The astronaut assistant task is special because of its combination of terrain traversal and arm use. We have designed our rover chassis to cross long swaths of uneven terrain, and we have designed our arm to handle objects up to 5 kilograms in mass. For accurately locating astronauts and the tools they need, we will use GPS and our onboard cameras. This year, we have created a dedicated business team concentrated on fundraising, marketing, correspondence, and team building. We aspire to operate our team more as a business than a club. We are fortunate to have strong support from the engineering departments at the University of Washington and our continued sponsorship from Tap Plastics, Janicki, Interlocks, and Wells Fargo. We have fully utilized our ProtoCase sponsorship, and we are thankful for their cooperation. In addition, we have started a new crowdfunding effort with UCR. As a result of this additional funding, we will be bringing more members to the competition this year. The remaining mechanical parts for our rover have been ordered, and the final electronic components will be purchased in late March. The science station is in final assembly and will go into sensor calibration next. We plan on having the rover chassis and arm functional by early April to begin field testing and code development. We will have several months of adjustments, fine-tuning, and refinement until we leave for Utah in May. We'd like to thank our sponsors, and we'd like to thank you for your time and consideration, and we look forward to seeing you in Utah.